In this podcast, I'd like to talk to you a bit about science notebooks that we went over last week on that podcast, and I gathered a score from you in class. But let me just remind you that my understanding and research that I've done and everything that I've read as an educator leads me to believe that one of the best ways to help people learn is if they are in control of their own learning. And one of the ways to do that is through a science notebook. And then as a class, early on, we agreed upon what would go into absolutely every entry in a science notebook. So here's a reminder of that. You can quickly look down that side and you can see evidence of that on the right-hand side. But we've decided that at a minimum, you'll have a title for every entry. And that means every day that we're together, that should be a new entry. And then the date will be included there. You've got diagrams, labels for the diagrams, add color if you want. That really helps enhance the effectiveness of a science notebook. You should be asking yourself questions, and as you come up with answers to those questions, you should go back and write the answers to those questions, and also notes that you take either in class or as a result of looking at the podcast. Well, let me show you. This is an actual scientist notebook, just to give you an idea and a reminder that this is what scientists do. This is from an ornithologist, a person who studies birds. He was in Yellowstone Park, and you can see by the date it was 2002. He saw a laughing gull. He drew a picture of it. He indicated he labeled the parts. In this particular case, I don't see any questions or answers, but maybe that was on a different page of his notebook. But just to show you that scientists actually do utilize science notebooks. What I'd like you to do right now is pause the recording and go back to your notebook and revisit it. And take a look and see if you are including each of those agreed upon items in your notebook. And if you're not, would you stop right now and add those to the most recent notebook entry that you have? You only need to do that for one entry, the most recent one, the one we did last Thursday. Now that you've had a chance to take a look at your science notebooks, let me introduce another concept for you that we're going to deal with the next time we're together. So we've been playing with this notion of creating a model. It's kind of what you see in that lower left-hand diagram, that you had an idea, you've made some observations about the minerals and the rocks, you've created some expectations, and out of that you've built a model, and the little diagram over on the right-hand side at the bottom is an indication of what your model might be. And again, models represent things, so it could be three-dimensional, it could be on paper, it could have just words on it. It could be like an identification chart or a key. Lots of different things create a model. What we're going to do now is move from the model that you've created to arguing for the model. And when you argue, you're arguing from evidence. So you've created this model based on the evidence of what you've observed, what you know about minerals, what you're learning about igneous rocks. And when we use the term arguing in science, it is not a bad term. It is a good term. We are trying to get other people to understand where we're coming from. Our argumentation is always based on evidence. So we can't just make something up and say, well, I think it's this because da-da-da-da-da. You need to say something like, I believe it's this because of the data that I've collected. Here's the data that I've collected. So you always are arguing from evidence. Argumentation is used to persuade others to your interpretation of the evidence. Two people can look at the same body of evidence and draw different conclusions. So what you're trying to do in argumentation is to lead other people to your viewpoint. Argumentation is always open to disagreement. It's always open to challenges. So keep that in mind as you are developing your argument for whatever evidence you are trying to present. So where does that bring us when we're together next Thursday? What I'm going to have you do is I probably will start the class with about 15 minutes to give you a chance to go back and revisit your model, to work on any pieces that you feel like you still need to complete. And then I'm going to come around with my iPad and I'm going to take a picture of your model, and then in groups I'm going to have you come up and I'll project your model up on the screen, and then I want you to argue for the model. And the rest of us will be looking at your model, listening to your argumentation, and I'm going to encourage us as an audience to respectfully, in love and with grace, to challenge you, to ask you questions about your model, to clarify anything that we don't understand, so we can enter into that scientific dialogue about how we create argumentation for models. And when we come away from the activity, we might have one model that we agree really helps us understand how we get from minerals to igneous rocks. So that's where we're headed. And again, I encourage you to do work outside of class to prepare yourself for the time that we do have together on Thursday mornings. Thanks.